Now that you know how to calculate molar mass, we're actually going to take it back a step and realize that if you have a pure substance like a diamond, it's made of just carbon. So there's no fancy math to do for the molar mass of something that's just a single element. The molar mass of carbon is 12.01 grams per mole. So you don't have to do any like adding up oxygens with carbons and all of that. Diamond is a pure substance. If it's a pure diamond, it's just carbon. Now, what if a weirdo says to you, I bet you can't tell me how many carbon atoms are in this diamond? Here's what you can do because you're smart. You can put that diamond on a scale, and the scale might say that the diamond has a mass of 30.0 grams. Just from the mass, you can use that number to calculate or estimate how many carbon atoms are in there, because you know you can't count them one by one. It would take you like a billion years. Now, you have to know a couple things. First of all, you've got to know the molar mass. So we already have the molar mass of a pure carbon substance. It's just 12.01 grams per mole. Look on the periodic table and you'll see it's right here. But you'll need something else as well. In addition to the molar mass, you're also going to need something called Avogadro's number. So Avogadro, and I'm using green because of avocados, Avogadro's number, which can often be abbreviated as just N with a subscript A, is a number similar to how you know that a dozen, so 1 DZ is equal to 12 things. Avogadro, almost said avocado, Avogadro's number says that 1 mole of anything, so we think of a mole as just a noun that tells you a number. 1 mole of anything is equal to 6.02 times 10 to the 23rd things. We often just call them particles because that's what we usually are referring to. Because a mole of anything you can typically literally pick up, like a mole of sand or a mole of babies or school buses, is going to be massive amount. This number is huge, but it's extremely important in chemistry because it allows you to count things without literally physically counting them one by one. Here's how it works. Let's take what we know here. We have that the mass of this diamond is 30.0 grams, and it's 30.0 grams of just carbon. You don't have to put that C there, and if you're in physics, you're like, is that a coulomb? No, it's just C for carbon. You don't have to do that. Matter of fact, I'm going to remove it because we're not changing elements and we're not doing stoichiometry, so we just know it's 30 grams of diamond, or 30 grams of carbon, which I can put over 1 because it's just itself. Then we're going to go to the next thing, which is we got to get rid of grams. So when you learned about dimensional analysis, we weren't kidding when we said it's going to be extremely useful. So we have 30.0 grams of carbon. We got to get rid of grams of carbon. So we're going to use the molar mass. We're going to put G in the denominator so that it will cancel out. And where are we going from there? We're going toward moles. Look at this ratio here. This is a conversion factor. Molar mass is a ratio that you can use as a conversion factor to convert grams to moles or moles to grams. In this case, we're converting grams to moles. What numbers will we put there? Well, the conversion factor says that 12.01 grams of carbon is the mass of a mole of carbon. And that's where Avogadro's number comes in, because literally we also know, by the way, that 1 mole of anything, in this case carbon atoms, is this many carbon atoms. So we're going to go one more step here. We're going to put our multiplication symbol, we're going to put our fraction bar, and now we're going to use a different conversion factor. We're going to put moles in the denominator. The word particles has a lot of meanings. It can mean atoms or molecules. In this case, because carbon is a single element, we're going to use atoms instead. So you could have put particles, or you can put a slightly more specific term, in this case is atoms. But 1 mole of anything, in this case carbon atoms, is 6.02 times 10 to the 23rd atoms. It's a huge number. But the good news is you don't have to count all those atoms in the carbon or in that diamond, because you just did the math for it. Moles cancels out, atoms does not. Now we can do our math here. So we have 30, and we're multiplying that by Avogadro's number. So I'm doing it live, 6.02 times 10 to the 23rd. And then we divide that by 12.01, and we get a really large number. But it's still much faster to do it this way than to take a billion years to try to do it on your own. We get 1.5 approximately, so we're going to round, 1.5 times 10 to the 24 carbon atoms. That's how many carbon atoms are inside this diamond. And the great news is you didn't have to count them one by one. What you did was you took the mass of that substance, you divided by the molar mass to get moles, and then you multiplied by Avogadro's number to figure out how many atoms there were. That's how you count things without having to count them. You really just counted them by weighing. Saves a lot of time.